Hi everyone, this is Math 133, Calc 2. I was assigned Chapter 6.7 of hyperbolic functions, and I was given to compute the integral of tan hyperbolic of 5x dx. So let's get started. So first, I'm going to start with the trig identity, which is going to be the integral sine hyperbolic 5x over the cosine hyperbolic 5x. From here, we're going to want to use u substitution, so I'll write that out. And our u is going to equal the cosine hyperbolic 5x, which is the bottom of that fraction. We're going to have this, which is the sine hyperbolic 5x 5, which is taking the derivative of the inside for the 5. From here, we're going to want to use chain rule. And for chain rule, we're going to want an f and a u. So our f is going to equal the cosine hyperbolic of u. And our u is going to equal 5x. And we're going to want to lay this out. Put some parentheses around there. Then we're going to want to separate this and take the common derivative of both of these. So first I'm going to start with the cosine hyperbolic of u, which then goes to the sine hyperbolic of u. And this one I'm going to take over here. And this, we're going to want to take out the constant, so I'm going to have my 5 out front. And this is going to be 5 times the 1, which is going to equal my 5. So then I'm going to take both of these and multiply them. And then I'm going to want to substitute my u back in from up here. Oh, it's off the page a little bit. So all I did here was bring my u, substitute it back in. Take a new piece of paper. From here, we're going to have our du This is what we just finished on the other paper. And we're going to want to switch these two around, have our dx equal it, and take that into a fraction. It's going to be du. All right, and we're going to want to break this fraction down. So we're going to have the integral again. Sine hyperbolic of 5x. It's going to be over u multiplied by, oh, the paper's crooked, multiplied by my 1 over sine hyperbolic of 5x multiplied by that 5 at the end times du. Then we're going to want to simplify this as fractions. So we're going to multiply these. We're going to get a sine h times 5x times the 1 on the top. On the bottom, we're going to get get a sine u sine h. These two can cross out. That'll leave us with a 1 over u times 5. This can multiply down even further to 5u du. Then we're going to want to take out these constants. So we're going to have our fraction times our integral 1 over u du. Then we're going to want to find our common integral. Write that over here. Which basically is the integral of 1 over u du is equal to the natural log of the absolute value of u. So from here, I'm going to get 1/5 natural log of the absolute value of u. Alright, and all we got to do is plug in. So that's going to equal 1/5 natural log the absolute value of u, and u from the other page, if you can remember, is cosine hyperbolic 5x absolute value. We're going to add that plus c at the end. And that is our answer for the first problem. Put these next to each other so you can see the final work. And that is it. My next problem asked if it was true or false that the derivative of f of x is equal to x to the power of sine h, or hyperbolic, of 5x, is given by the derivative of this huge long answer. So I'm going to see if that's true just by solving it out. So I'm going to start with the exponential rule. So the exponential rule is basically a to the b is equal to e to the b multiplied by the natural log of a. So for mine, I'm going to have the dA over dx. This is going to be e sine h 5x multiplied by the natural log of x. From here, we're going to want to do the chain rule. So for the chain rule, we're going to need an f and a u. So our f is going to equal e to the power of u, and our u is going to equal sine of h 5x natural log of x. And then from here, we're going to want to solve. So I'm going to put this in this form, solving for a derivative. And then we're going to break these two apart and solve them. So for this first part of e to the u, I'm going to find the common derivative, but for e to the u, it stays the same. And then for this part, I'm going to solve it by doing the product rule because these two are multiplied together. And for the product rule, I'm going to need an f, a g, an f prime, and a g prime. So for the f, it's going to equal sine h of 5x. My g is going to equal the natural log of x. And my f prime, I'm going to solve this by the chain rule. So for the chain rule, I'm going to break it apart. Then from here, I'm just going to solve. So the sine of h is going to go to cosine of h. And then I'm going to bring this u, it's going to be my 5x. And then this I'm going to solve, and that's just 5. So that's my f prime, then my g prime. I'm going to get this from a common derivative, so I'm going to write this out. And when you take the derivative of this is just going to equal 1 over x. Okay, now putting this all back together a little bit. All right, and this is gotten from plugging in all these different parts that we found so far. And then this part, we're going to want to switch around a little bit. So I'm going to put this on the next page. And that we can simplify. I'll write it out again. We want to get rid of that this fraction right here. So we're going to multiply. And we're going to want to multiply again. Okay, then we're going to take what we had earlier on the bottom of that last page and just add in this instead of this. So that's going to equal okay. So this is going to be our power. So then we're going to want to plug this back in to our e to the u. So instead, I'm sorry, not to the power, but I'm multiplying this by the power of e to the u. Okay, then from here, I'm going to want to bring back the u substitution. So I'm going to fill in for this u. That's where I'm going to fill in. So then this is what we got earlier. And then still multiplied by this. Okay, so this is a lot right now. So I'm going to start by simplifying this power. To simplify this, I'm going to use the exponential rule. So basically, I'm just going to want to bring this natural log in. From here, when I look at the e to the power of ln of x, I can use the log rule, and that, so e to the natural log of x actually equals x. So now we have x to the power of sine h 5x. Okay, so now we've kind of simplified it as much as I can see how to do it. So now I'm going to plug this back in. So now it's going to equal x to the power sine h 5x multiplied from what we had still from earlier. So all of this. All right, and that is my answer. I'll bring back this other piece of paper. And you can see that this is false because the function of f to the power of sine h of 5x, the derivative is this. All right, thank you.